Hello. Hi, my name is Hari. Hi, my name is Hari. Hello. Hi guys, are people watching right now? Is anyone watching right now? Hi guys, are people watching right now? Is anyone watching right now? Hi guys, are people watching right now? Is anyone watching right now? Is anyone watching right now? Hi Jasmine. Should I? Okay. I'll go ahead and start. Should I? Okay. I'll go ahead and start. Okay, so this is about optics. Optics, if you explain it in two words, is the study of light and its motion. How you manipulate the light waves and how light waves are packaged, how light waves are manipulated in devices such as optics, if you explain it binoculars, microscopes, is the study of light and its motion. How you manipulate the light waves and how light waves are packaged, how light waves are manipulated in devices. So for the description of the event, so there are two parts to the event. There's a test, and you have to have an activity. In the test, you will be tested like on a regular test you might see, but all the topics are in the rule book. The rule books are can be free source portal, and for activity, you have and you have to have an activity. You have to manipulate a laser and hit a certain target using mirrors. And there's more complications to that, obviously, but then the rule books are. This is the general overview. Resource portal. So before you do the test, you must have lots of practice on the concepts and different problems that you might encounter, vocabulary, formulas, and stuff that you should know. And for the activity, you need to you should build a general. So before all the members should come together and build the setup that they must use in the actual competition, which can be seen over here. So everyone should come and build this thing. So it'll be beneficial to the entire team. And everyone can help build the setup that they must use in the actual competition. Okay, event parameters. So you have a 3-inch ring binder. So in that binder, you will put all the information. You put all the information in the event into the binder. Okay, so you can't just go Google and research everything, just cram into that binder. So you have to actually know the content, and then you have to have a firm understanding of all the topics they can ask you, so you don't just frantically look around for pages in the Google document. So in the activity, you are timed, so more practice makes perfect. So the actual setup will involve a laser, which can be seen right here, and you will have a ruler on the other side, which will show where the target should be. So you're supposed to manipulate that laser through mirrors. The mirrors will involve, you can, there are a set amount of mirrors you can use, which is 5, and the more mirrors you use, the better. Show where the target should be. So you're supposed to manipulate that laser through mirrors. So there are obviously more complications to this, which can be seen over here. So people, you get timing, you get 4 minutes, and then the laser can't be turned on until the timing stops, and you can't touch the laser. You can only touch the movable mirrors that you get, and you get 5 mirrors. So, and the scoring, there's multiple parts to the scoring. There's mirrors. There's a mirror scoring, which shows how many mirrors you use. The more mirrors you use, the better. There's an accuracy scoring, which measures how far away you are from the ruler target. So and the scoring,
and then
there's multiple parts to the scoring.
there's also a
There's
final,
mirrors,
and then there's a barrier score, which is
which
5 points
how
if
many
the
mirrors
laser
you use.
reflects
The
off
more
the barrier
mirrors you
mirror,
use, the
which is
better.
the
There's an accuracy
mirror that
scoring,
they
which
provide in the competition.
how far away you
So
are from
you
the
have to
ruler
know
target.
which can be randomly aligned.
And the
So
scoring,
and
better
then if you experiment more with the
there's also a
activity
final,
setup, you will
and
do
then there's a
better in
barrier
this
score,
one.
which is
5 points if the laser reflects off the barrier mirror, which is the
there's an accuracy
mirror that
scoring,
they provide in the
measures how
competition.
far away you are
So
from the
there's a lot of
ruler target,
content
which
in
can be
this
randomly aligned. So
in this event, and all of these topics can be found in the rules book. So you have the law of reflection, specular, diffuse, refraction, index of refraction,
there's a lot of
uh,
content which can
and
be
all these
randomly aligned.
various topics that I'm going to go over in
all of these
a general info to give you guys a general info. But you don't need to worry about the Division C at state and national tournaments yet. We'll be doing. You guys should focus on all these important topics first, and then afterwards, once we finish regionals, you guys should or you should start looking at it before regionals, but then you guys should focus more in depth after you finish regionals. So going over the different topics. So there's reflection in optics. It's physics based, so everything will involve like motion and things that you might see like just how formulas are used and there are different laws and different properties for light. And this is a very great resource which is called scioli.org, and if you go to slash the optics sub page, you can find all this information. So I'll go over this in the general detail right now. So reflection is states that the law of the law of reflection sub page, you can find all this information. So go over this detail right now. So reflection is states that the the law of reflection sub page, you can find all this information. Hello? Yeah. Yeah. But how do you mute your laptop then? Yeah. Hello? Yeah. Yeah. But how do you mute your laptop then? Okay, does it work now? The audio? Yeah. Is it saying what I'm saying right now? Hello? Yeah. Yeah. But how do you mute your laptop then? Okay, does it work now? Okay. The audio? So I'll go ahead. Yeah. Is it saying what I'm saying right now? Hello? Okay. Thanks. Bye. Yeah. Okay, so that was a bit of a technical difficulty. So the law of reflection, okay, basically what it says is once if a light wave in the light wave the ray hits a boundary or a surface, then it will be reflected off from the same angle, and it's called the angle of incidence. The ray that comes in and the so the law of reflection and the thing basically it will be the outgoing ray. So there will be two angles. The angle that makes to the horizontal, the two rays, the both the angles will be congruent. That's pretty standard. And then there's refraction, incidence, the ray that comes in, and the so the law of refraction is basically how light changes speeds throughout different mediums like air, water, glass. Light has a different speed in air than water, which causes sound and just like sound. So it would so light would be you would see light at a different time than you would in air or water, but the difference in real life is not that much. So you wouldn't be able to notice speed in air than water, which causes sound. Hello, just like sound. So it would so light would be hello. You would see light at a different time than you would in air or water, but the difference in real life is not that much. So you wouldn't be able to notice speed in air than water, like this. Sound. Wait, it's lagging, right? Just like sound. So it would. So light would be. Hello. You would see light at a different time than you would in air or water, but the difference in real life is not that much. So you wouldn't be able to notice speed in air than water. Okay, what should I do? Wait, it's lagging, right? Just like sound. So it would. So light would be. Okay. Hello. You would see. Is it working? Hello. Oh, okay. Okay, so it's working right now, right? Okay. Okay, thanks. Bye. So there's a lot of vocabulary that you must know. So you guys should go to this website and understand all of this. So and then in image location for mirrors, there are different um, things that they can give you, and this is like the mirror that they'll give you, which in this case is convex or yeah convex, and then this is the perpendicular ray. So as the ray reflects off and the mirror there, it creates different waves, and you have to calculate that you might have to calculate how these rays are go and how and what angle they make to the horizontal and stuff like that. So this would be another setup. So they might give you different trials, and then they might ask you which one is correct and which ray which ray comes out from the mirror correctly. So other than just the optics part, you will be asked questions about the eye, which the eye of the human eye and how it perceives light. So there are different different parts in your eye that make this possible, such as the cones, cornea, iris, lens, optic nerve, retina, rods. You guys, this would so this will this tells you all the details about the eye, which what it does specifically. You should go onto Google and research more about this, because this site does not give you everything in detail. So this shouldn't be your only resource. And you will also be asked colors and the color and primary, secondary colors, which is a topic over here. Visible spectrum. You will need to know additive, subtraction, absorption, reflection, and then so this is the general overview of all the different topics right now. Okay, so now moving on to sample problems. So this is a sample problem that was found in a previous year test back in 2012, but it is very relevant to this year's test as well. So it says, still considering the diagram on page 1, the object's focal distance is 22 centimeters and the object's distance is 11 centimeters. Calculate the image distance. Show your work, including the formula. So if you go over here, there's a set of equations that you can use, a set of equations that are important and necessary to like understand in the optics test. So what it asks for is the image distance. Oh, and then you look at this formula. Oh, it says F is focal distance, DO is object distance. So this equation would work because it has three unknowns, and you know two of them from the problem. So you do the inverse of the focal distance is equal to the sum of the inverses of the object and image distance. So you would, for this problem, you'd say 1 over 22 equals 1 over 11 plus 1 over image distance, and you would solve that. So if you want to draw a concave lens, you can, so the concave lens will be positioned like with the circular thing, and it's similar to these ones you see over here. These mirrors you see over here, these ones are called concave lens. I mean, no, yeah, these ones are convex lens and these are concave lens. They have a cave coming out of them. So when you see a cave coming out of them and it's not enclosed, that means it's a concave. But convex is enclosed circle like that. So it says draw a convex mirror. Mirrors are basically the same thing, except they have you can see like hairs going, like something similar to like lines cutting through the lens. So that means it's a mirror. And to see the and you want to know the focal distance of all these types of lenses and mirrors, you must you need to go and understand how these lenses work and how they perceive light differently compared to like a concave, but concave is convex. So there are multiple resources that you can use, and the one that I was using is called scioli.org. This will give you a general overview of the event, but it won't give you everything in detail. And so to know the physics behind the actual optics, you guys should go to this textbook link called cnx.org, which gives you 3 chapters on just optics. And the one that you should focus on most is geometric optics, which gives you, and this, you can see chapters 25, 26, and 27. They talk about light and the law of reflection, refraction, dispersion, rainbow, and prisms, which you will need to know for the test. Obviously, you don't need to memorize everything, but you should, by screening time, but you should plan on actually understanding these content and putting it in your binder where you will be able to refer to it during the test. Also, but this also doesn't cover every single topic that they might ask. So you should go to Google. You should go and see different science textbooks, which are usually the best. Tell you how each topic, more details on each topic. And the next biggest resource is you must actually go through the rules book. Make sure you understand it thoroughly and carefully. The rules book can be found in the resource portal. So you go to the rules book, which has 2017 rules book. So you go and you find optics, and there are many nitty-gritty details that the event supervisors will do. That, like for some building events, they'll make sure you're inside by tiny centimeter, and they'll take off points or disqualify you if you're out of the boundary. So you should make sure to read every single line and make sure you're following the event parameters. And then YouTube videos are a great resource. So I'll show this one YouTube video which I found online about how you should manage the mirrors to hit the certain target.
We will show you a block.
So you can see right over there that that laser is pointed correctly to the target, but you want to get that, but then initially it'll be given to you something like this where the laser is not correctly on the line. So you need to manipulate the laser so that it hits the line using mirrors. So there will be one mirror provided to you, and you can use up to 5 mirrors. So the one mirror, if you choose to use that one mirror, you'll get much more points than you actually would. And if you get all 5 mirrors, that'll be most beneficial towards your score. So you can see that's how a mirror would look like. It'll be called a front facing mirror. There are 2 types of mirrors: front facing, rear facing. Front facing is the standard mirrors that you can buy in hobby stores, and they just attach it onto a wooden block. So to actually get to be really good at this event, you should build this as soon as possible. Event captains will be there to help you and make sure that this falls within boundary, and then you guys should experiment on it a lot, and event captains and the vice presidents will make sure that you guys are good at this by testing you along the way. Do you guys have any questions? If this video was if the beginning was still echoing, I will probably go and record all the parts where which the echo came over and where you couldn't possibly hear it well, and I'll post a second YouTube video up soon. Okay. Thanks.